I'm trying again. Okay, looks like we're live. Okay, good afternoon. Welcome to the first session of the fall 2020 Sunoikisis Digital Classics program. This semester, the theme is digital classics, so we'll be talking mostly about things related to text encoding, to linguistics, and to various collaborative computational methods in the study of humanities, text, and history generally, with a particular focus on classics, but not exclusively. We're joined here today. I'm Gabriel Bodard from the Institute of Classical Studies in London. You see also on the screen Monica Berti from the University of Leipzig, who is the Matrina of the Sunoikisis program. You see Polina Jordanova from the University of Helsinki, who is one of our co-organizers this semester, and Irene Vagionakis, who is another of the co-organizers on this semester. We're basically taking responsibility for various strands within the program. So Polly is taking responsibility largely for the computational linguistics and linguistic approaches strand, Irene for the text encoding and markup strand, and Monica for the collaborative and visualization tools strand. And you'll see how that works if you look at the program, which you probably already have, but let me pull the program up on the screen just quickly. So this is the shape of this semester, and you can see it as 9 weeks of sessions, and there are roughly 3 in each strand. So there's weeks 1 and 6 and 9 are the collaborative tools and visualization strand. Weeks 2 and 3 and 5 are the text encoding and annotation strand. And weeks 4 and 7 and 8 are the linguistics strand. So there'll be a range of technologies there. Each of these, as well as having this YouTube session, which is live, will also have a session page for. They're linked on this page, and this will give you an outline of the session. It'll give you some readings, both some discussion readings and some further reading on the subject, and also a suggested exercise. So those of you who are following this as part of a course, that exercise may or may not be the same as the one that your tutor wants you to do. Those of you who are following for your own interest and edification are welcome to try out that exercise and get in touch and discuss it with us if you have any issues with it. So that's the come back to us. That's the outline of the program. Those of you who are watching this live, you'll see on YouTube in the top right-hand corner, probably, or below the video, depending on your interface, a live chat feature. Please feel free to pop into the live chat there and say hello, introduce yourself. It's always nice for us to know who's watching, and especially towards the end of the session, or in some of these sessions, there'll be other discussion during it. Please feel free to join in that discussion by leaving comments, leaving questions, and so forth, and we'll keep an eye on that, and we'll respond to your questions and comments there. If you're watching this after the event, so you're not watching this live, but you found this on YouTube and you're watching this later, welcome. You're extremely welcome to be joining us. We're delighted that more people are watching this, but unfortunately you can't take part in the live discussion unless you have access to the machine. So the theme of today's session is open source software and various tools for working with open source software. But we're going to talk primarily for the first half. I and then Monica are going to talk a bit about the theory and some projects in the area of open source and open scholarship and open philology. And then we're going to introduce some fairly basic tools. So apologies to those of you for whom this is old news. We're going to give a very quick introduction to the command line of your computer, and also to the Git software, which is a version control tool often used in open source and other collaborative tools. And the suggested exercise we have for this session is based on that tool set using the GitHub platform. So that's the general outline. Unless anyone wants to jump in because I've forgotten, I will start by pulling up some slides about open source and open philology. Attempting to share my screen. Apologies in advance if I freeze at any point. We've been having internet issues all day. So to go to my slides. Right. So in this initial session, I'm going to talk a bit about the concepts of open source software and how the licenses for open source software and open access publication compare to one another. And then I'm going to use that to put into context the concept of open scholarship, which in the digital realm is very much like related to the open source software model. But actually, open scholarship is what we've been doing ever since the Enlightenment. That's how university scholarship works in the sciences and humanities alike. So to start off with, open source software is a model. It's not a particular tool. It's not a particular way of doing things, but it's a model. It's a mindset. It's a culture of sharing tools and of sharing the source code behind those tools. What is sometimes referred to as the free software model, and that is often explained that it is free as in speech, not free as in beer. In other words, it is free as in no one can restrict what you can do with it, not free as in you have the right to acquire it without pay at all times. The two may both be true, but it's the first that is most important in the concept of free software. So free software is this collaborative software management model, and one thing that's worth stressing, because people aren't always immediately aware of this, is that there is a lot of private industry involvement in the development of open software. Of free software. So, if you've used, Unix, the GNU, Linux, Android, Google Chrome, operating systems and platforms like this, there's a lot of open source software going on behind the scenes there. Not all of these are completely free tools, but the developers of those tools put a lot of their funded time into the open source code that they're based on. The Mozilla and Firefox and Thunderbird operating system, web browsers and email tools, and the OpenOffice and LibreOffice document editing suites are again fairly well-known open source software environments that you may have come across. So there are various different open source licenses, and this is just one of them, the general public license of the GNU. And the point of this license, and the point of open source licenses in general, is that they allow the reuse and redistribution of the source code behind the software. So you may have a commercial piece of software which has to have been purchased, but the source code behind it, or some of the source code behind it, may be based on this open source model, which means you can download that software, you can take it away and adapt it, make variants of that, and then do other things with them. Some of them are licensed such that you can download the code, adapt it into something new, and then sell the stuff on it. Some of them will have a non-commercial license on it, that if you've used an open source tool, you can't sell what you've built on top of it. Some of them will allow you to lock down and copyright the derivative software that you've created built on that. Some will say if it's open source software and behind it, your tool has to be open source as well. Most do allow you to take away the source code, add your changes and publish your changes on them, not just use them privately. It's worth pointing out that because something is open source does not mean that it's in the public domain. Public domain means there is no longer any copyright on something. There is, a piece of literature that has been published for well over 100 years will be out of copyright. You could reprint that with your name on the front, and you wouldn't be breaking the law. There'd be no copyright law going on. I mean, it would still, within an academic environment, you'd still be considered dishonest for doing so, but it wouldn't be a copyright violation per se. Open source licensing is not necessarily related to the public domain. If you push something out under an open source license, you have to own the copyright on it in the first instance in order to be able to do so. What it does is it enables reuse in ways that strict copyright and the automatic copyright that derives on anything we publish would by default deny. The arguments used for this are often that the shelf life of software is much shorter than the traditional copyright. Copyright is, in most parts of the world, is something along the lines of 70 years after the death of the author. It's very, very rare that a piece of software will still be of any use to anybody 70 years after the death of the author. Even 7 years after the composition of that software is pushing it for software purposes. The collaborators on a particular piece of software may never meet or even communicate directly. That the tool may just be out in the open space somewhere that they both worked on, or multiple of them worked on. They may be using them for unrelated purposes and needs. They may even have conflicting purposes and needs, and so they may create forked versions of the code that have gone off in different directions and are no longer compatible. Most open source software is not just completely free and community driven in a in this sort of utopian and a disorganized way. It's often driven by a particular project or a particular company that are open sourcing it in order to get other people to help out with that code. In comparison to that, I don't want to go into so much detail, but when we talk about open access publication, you'll come across this all the time. Almost all of the readings that we give you as part of the Sunoikisis session pages will be open source publications, which means you can read them online without having to pay for them. That is what is meant by free as in beer. So open access publication means you don't have to pay money in order to get to it. It doesn't necessarily mean that the copyright is any different from something that is that you have to pay for. I mean, in most cases, it doesn't mean that. Although there are also open licenses that waive some of the copyright features in similar ways to the open source licenses. So, for example, course materials that people put online, web comics, newspapers, some online journals, all sorts of materials like that. They're open access in the sense that you don't have to pay to read them, but they are still fully copyrighted. You can't copy the content without permission, any more than you could from a print book that you purchased or borrowed from a library. A lot of the publications that publish in this open access way, they do so because their business model depends on a lot of people having access to their material. One example of this is newspapers who they produce a resource that people don't pay for the resource, but the advertising that is profitable because of the vast number of people who do read the resource is what pays for the publication of the paper in the first place. But there are other kind of business models that help to fund open access. From an academic perspective, open access is very important because we want our scholarship, our publications to be available to as many people as possible, including people from less well-funded universities who may not have vast amounts of this material in their libraries, including to non-academics, and including to scholars from all over the world, including countries who where access to expensive publications and libraries isn't always very widespread. We believe that our academic scholarship is a public good. In most places, our scholarship is publicly funded, or to some degree at least publicly subsidized. And we also know that the more open access our materials are, the easier it is for people to check the references and the more likely they are to cite those publications. Studies have shown that online publications are cited much more often than traditional print publications or things that are behind paywalls. So open access publications can be completely copyrighted, but you can also attach an open license to to your publication, which would waive some of the restrictions, the protections that automatically accrue under copyright law. So most open licenses will allow people to redistribute your work. So not only can you read my article for free on the website where it is posted, but you can take a copy of it, you can print it, you can give it to your students, you can upload it to your website, you can do, all sorts of other things to it. Most licenses require you, however, to keep my name on it when you do so. All right, because it's not taking, giving away my copyright. It's saying, here are some of the things that copyright normally doesn't allow that I, however, do want you to be allowed to do. Some licenses allow commercial use, some allow non-open use, and some allow transformative use. We talked about some of those under the open source licenses. So again, an open licensed publication is not necessarily in the public domain. If it's in the public domain, there are already no copyright restrictions stopping you from doing, from distributing it, from taking off the name of the author, from selling what you've made out of it, from locking down what you've made out of it, and from transforming it into something completely different. Those are all fair game already. The Creative Commons license, which I won't read out in full, are the most common open access licenses of this kind. They work alongside copyright. They waive some of the restrictions that will automatically come accrued through copyright. And here are the main variants of that. Attribution, basically every license requires attribution. Some licenses, share alike, requires your publication to be open access, to be open access and licensed under the same restrictions as the one you based it on. Non-commercial means you cannot sell the result of your work. No derivative means you can reproduce the, you can't modify and recirculate that. And so there are various reasons why people will use open licenses. If you want people to reuse and remix your content, this allows you to test, to build on the original science. If obscurity is a bigger enemy to you, to your business model, than piracy would be, and a lot of independent bands who publish their music under open licenses, self-published authors sometimes use open licenses, that's how they come into this. If you want your work to be something which other people build on, and an example of that is Wikipedia, very obviously, and academic work, probably a combination of all of these, plus the fact that we believe our work is a public good. And so finally, under this heading, I want to talk about the concept of open scholarship, and here this is not something that's specifically digital. So in 18th century Germany, the concept of the free university was basically invented, and this was free as in speech, not free as in beer. You might have still had to pay fees to go to some of these universities, but they were free and they were independent from both the church and from government. So what you studied and what you taught and what you learned at these universities could not be restricted either by the king or by the church. And this model established the need for rational argument. So you could no longer say this is true because I, the great professor, say so. You had to say this is the argumentation behind it. This is the evidence which you reproduce. This is the methodology which you could try out and see whether you reach the same conclusions, and you cite previous scholarship. You don't pretend that you completely invented this argument. You build on scholarship that came before, and you acknowledge the scholarship that came before. So the traditional method, and this has been the case in most disciplines since the 18th century, and of course longer, right up to now, is that one scholar will do some research, and they might spend 20 years doing this research. They write a book which includes citations to their research. That book is published. That scholar then retires, dies, whatever. 30 years later, another scholar finds that book and follows the citations, reproduces some of the arguments in it, disagrees with the results or wants to build on those results, does new research, and some years later writes another book, which includes the first scholar's book in its citations. Those two scholars have therefore collaborated, even though one of them was dead before the other one started the work. Right? This is what we call asynchronous collaboration. And this is, over a long period of time. In open source software, exactly the same thing happens, but it's over much shorter time scales. In experimental physics, that's exactly how the scholarly method works. You cite earlier theory and experiments, you credit all collaborators and people whose work you've cited, and you document your experimental method so that others can reproduce it. In theoretical literary criticism, this is exactly how it works. You cite earlier critics, you credit the proponents of your theory, you document your argumentation, and you footnote everything. In classical philology, the same model. We have apparatus criticus, which cites scholarly differences with early publications. We have bibliography, crediting people for editorial restorations that we're adopting. We have historical commentary, which argues for our interpretation, and we publish photographs, facsimiles, comparanda. We tell people where they can go to museums and libraries to find the originals, and things get republished regularly. Regularly may mean every 50 years, or it may mean much more frequently than that, depending on the material. This is, therefore, asynchronous collaboration of the kind we talked about. The scholarship allows reuse within certain parameters. If I couldn't reuse your philological publication, I couldn't build a future publication on it. So certain things that I can reuse that, if it was strictly copyrighted in the normal way, wouldn't be possible. Attribution is, however, always required. The source code in software terms, by which we mean the evidence behind our thinking, is made available alongside the binaries, which is the published argument, such that people can reproduce that experiment. The thing that requires us to do all this is academic protocol. If I don't work this way in academic terms, I'm not being a good scholar. I'm not necessarily breaking the law, right? This is saying the same thing in different words. And I just wanted to make the final point about remixing. When we talk about remixing, which is a metaphor from music, I guess, where people can take bits of earlier songs and incorporate them in their own material. In digital scholarship, remixing is absolutely imperative. We have to be able to get hold of your raw data and get hold of the software that you've used or the algorithms that you've used, and use either both to reproduce your method or use just one of them in a slightly different context to take the scholarship forward, to take the discipline forward. And this is why the open source model then is absolutely essential to modern scholarship in the digital area. On which note, apologies for being very slightly behind schedule. I'll hand over to Monica to give a concrete example of all of this.
Okay, Gabi, thank you very much. This introduction was very important also for my part. And hello, everybody. Of course, I see that there are questions also in the chat. But now I'm going to talk about Open Greek and Latin as an example for open access and open data in classics. And I can show, I hope you can see my screen. I'm showing now the web page of Open Greek and Latin. So Open Greek and Latin is a project, is an initiative, part of Open Philology, which is a project that started in 2013 at the University of Leipzig as part of the Alexander von Humboldt Chair of Digital Humanities. And the goal of Open Philology is to provide open access and open data for historical languages with a main focus on Greek and Latin. The project includes also other languages, and in fact, we also have two projects like Open Persian for classical Persian and Open Arabic for a corpus of pre-modern Arabic texts. Today, I'm just briefly mentioning the Open Greek and Latin because, of course, here we have many historical languages. Open Greek and Latin is focused on, as I said, on Greek and Latin. In this, you can access the website of the project. You can see it on my screen. And here, as you can see, there are different sub-projects and different institutions involved, not only Leipzig, but also Perseus project, of course, which was the first project providing open access and open data for Greek and Latin. Then we have the first 1,000 Years of Greek, which is a project of the Center for Hellenic Studies at Harvard University. LACE also here, as you can see, which is important for OCR of ancient Greek, and then also other institutions like the University of Virginia Library, Eldarium, a company producing the Scaife viewer, which is a reader for data produced through Open Greek and Latin and Perseus, the Harvard Library, and then, of course, also the University of Leipzig. If you're interested, you can access these resources. You have the link in the session, in the outline in GitHub, and you can explore, you can get a description of these different institutions and sub-projects. The important thing is that Open Greek and Latin produces data about text in Greek and Latin. Originally, the project, as part of Perseus, was providing just the text, the reconstructed text of Greek and Latin sources. But now, with Open Philology and also with the first 1,000 Years of Greek, the idea is also to provide editions, complete editions, of course, out of copyright, where we have also other parts, like the critical apparatus, introductions, indices, etc. There are two important links here in the web page of the Open Greek and Latin, where you have a link to the Scaife viewer. I'm mentioning this because this is a new reading environment for reading and also for annotating text produced by Perseus and by Open Greek and Latin, and also for getting information, for example, about the morphology and the syntax of these texts. And then also another link here, Canonical Text Services. I'm not going to talk about this, but this is a project for producing canonical citations and unique identifiers of classical sources, which are, of course, fundamental for many different purposes. And you can find other sessions in our repositories in GitHub for Sunoikisis concerning the CTS, the Canonical Text Services, and the site architecture. Anyway, if you access this web page, you can also access data, as you can see, data sources for the text libraries, and here you have different links to GitHub. Later we are going to talk about Git and GitHub, and here you can find concrete data for accessing these resources. And these links, they provide access to the first 1,000 Years of Greek. You can also have access to LACE if you're interested in OCR in ancient Greek, and then there are other specific repositories for Greek and Latin data. And here I'm going to briefly show you the first repo in GitHub. This is a part of the Perseus Digital Library, which is part of the Open Greek and Latin. Perseus, of course, was the original project, starting more than 30 years ago to produce open data for Greek and Latin. And within Perseus...
Monica, could you zoom in a little bit, please?
Yes, of course. Thank you, because of course I know that in YouTube it can be smaller. I hope it's okay. So here you have the first repo, okay, in Perseus DL, Digital Library. You have Canonical Latin and Canonical Greek. So through these two repositories, you can access Latin and Greek data. Of course, it's quite straightforward. And within each repo, like in this case, Canonical Greek Literature, you have, of course, a description of the repo, of the data, but you have a subfolder where you can find actual data. And as you can see, data are text, in this case, text of Greek literature, and they are arranged by TLG numbers, which means that each of these numbers refer to the number of the author in the Thesaurus Linguae Graecae, okay? And I understand that you can't remember the number of each author, but if you're looking for a specific author through the number, you can look for it through the Perseus catalog, okay? In this case, for example, if I look for Herodotus, I can get, okay, the number TLG 0016 is the number of Herodotus. And within the folder, for example, TLG 006, I find, of course, that in this case, for example, I have the Greek text of Herodotus, an XML file, and also an English translation of the histories of Herodotus in the form of an XML file. The same is for Latin, of course. There is another repo where you can find data for Latin authors. In this case, folders are arranged by numbers, PHI numbers. Also, in this case, if you don't, of course, know the number, you can get it through the Perseus catalog, where you have a complete list of metadata about authors and works of Greek and Latin literature, and you can access, okay, these folders. And we keep numbers according to the TLG or the PHI because they are important also for producing canonical citations. They are unique and they are standard today instead of using names, okay, of authors and works. And finally, I mentioned also another important repository within the Perseus Digital Library GitHub main repo, which is the catalog data. The catalog data is the repository where you can find data for the Perseus catalog, which is the catalog of the Perseus Digital Library. And this is very important because you can get through this repo a lot of metadata about authors and works in the Perseus Digital Library, and not only, because this data includes information about many editions of authors, and you can also find authors not available in the Perseus Digital Library website. Okay, this is important. So if you want to get more works and authors, you can access through these repositories. And in particular, there are two important folders: MADS Primary Authors, which is a folder about catalog authors, and you have files in the MADS format, the metadata authority description schema, which is a particular library schema, XML schema, for metadata about, in this case, classical authors of Greek and Latin literature. And then mods, another, and here you can see very briefly, okay, the subfolders, in this case arranged by the first letter of each author of the Perseus catalog, and then the other is the mods folder, where you have, this is another standard metadata object description schema, which is another XML schema used by digital libraries for representing metadata about bibliographic records. In this case, this standard is used for, as you can see, Arabic literature, also you can find here, and then Greek literature and Latin literature. And within each folder, you can find a subfolder, also in this case, where you have, of course, works, and then within you will get XML files for works with the specific metadata. And this is one important thing is the goal of the Open Philology project and of Open Greek and Latin is to provide open access and open data. Open data because, as you can see here, you can access for free data, concrete data with classical literature, but not only you can access the data, but with specific accessible and reusable standards. So this is the important thing, not only because you can access for free this data, you can reuse this data, but also because this data is encoded with standards that now are used and established in the community of digital classics, but not only the digital humanities in general, and so you can reuse this data, and you can also contribute to this data if you're interested in that. So this is the spirit of the project, open access and open data. And this data is licensed with the CC license, the share alike license. And of course, we can provide access to data that are, of course, free of copyright. So there is a lot of work in the Open Philology project for copyright issues, especially because we are publishing data, we are providing data not only with the reconstructed text of classical works, but also critical editions. And in fact, there are different rules for providing the main text, the reconstructed text, and in other cases also the critical apparatus. And the two components of a critical edition can have different copyright situations, in the sense that maybe you can publish the reconstructed text, but not the copyright. Of course, this depends on how many years are from the publication of the critical edition. Now, of course, I can't talk about copyright issues, of course, also because there are differences in different countries. But anyway, there is a lot of work in the Open Greek and Latin project, in the Open Philology, also for the copyright issues. And in this case, we are also working a lot with libraries, physical concrete libraries that are providing a lot of OCR material and PDF copies or images of books, scans of books. And there is a lot of work with these institutions concerning open access and copyright regulations. So I think this was my part. So this was a brief introduction to Open Greek and Latin. So I don't know if there are questions or.
So there was one question in the chat, which I think I've answered, which is Open Persian ancient Persian?
Is classical Persian, I can say this. So it's classical Persian, and I can also, yes, you have the link. No, it's not exactly. It's a classical Persian. Yeah, and in this case, there is a lot of work also for producing translation alignments and new translations of Persian's text. Yeah.
So I wondered if it was worth saying a few words about a little bit more about copyright of ancient text and of data based on ancient texts, because I talked a bit about academic nicety and having complete freedom to cite other people's apparatus criticus and so forth, and we saw examples there of Creative Commons licensed raw data and so forth. And I wonder if it's worth saying a few words about to what degree it is necessary for us to put an open license on something that is an ancient text, and by the same token, to what degree it's even acceptable to try and put an open license on an ancient text. Do you have thoughts about that, Monica?
Well, the problem is that, yes, we're talking about ancient texts, ancient authors, but we depend on modern editions, because in any case, for these texts, we always we always use modern editions. So we are not providing, for example, transcriptions of manuscripts. Technically, we can do that. If a scholar is producing a new edition, he or she can decide to publish this data as open data in Open Greek and Latin. As for now, what we have are OCR versions of modern editions. So this is the problem. Unfortunately, we have to deal with the modern editor, so the editor of the ancient work, of the ancient text. And in this case, there is a difference between the main text and the critical apparatus. For example, today we can publish the critical apparatus 25 years after the publication of the critical edition. In other cases, we still have to wait 70 years after the death of the last editor. So there are different rules. And in fact, for example, through SLAB, which is the National Library in Dresden, you can find online images of those texts where you have the main text, but the critical apparatus in the PDF is covered, is in the image online. So still we have these issues, and unfortunately, yes, we have to deal with the modern edition. So technically, we don't have copyright for ancient authors. Yes, it's true.
Cool. Thank you. Yeah, I think that was useful to unpack that a little bit. Yeah.
And sorry, this is important for our audience, for students in general, for users. Always be very careful the data you're using. Always check the copyright situation. So if you can use data, if you can use this data, and if you are producing new data, of course, our recommendation is to use a license to protect your work. And then you decide, of course, you're responsible, and you can decide if other people can reuse or not, etc. But now you can really find a lot of information online in this sense.
Yeah. Great. Okay. There are many more people still in the comments, mostly introducing themselves. So I don't think there's any immediate questions, but we can look again at the end. Shall we move on with the session then? We're now moving on from the general discussion to a couple of fairly technical, and again, I apologize because 50% of our audience will find this extremely basic, and the other 50% will find it absolutely horrifying. So bear with us from both sides, please. So Irene now is going to introduce the concept of using your command line.
Yeah, thank you, Gabriel. And so now I'm going to introduce you the command line, and I start by sharing my screen. I hope you can see my slides.
Yes.
Okay, so first of all, what is the command line and what is it for? And the fundamental concept here, both on Windows and on Mac or on other operating systems, is that most of the actions that you can do through a graphic user interface, that is by clicking on icons on your desktop or dragging them, these can be done also by typing commands in the command line, that is giving instructions to the computer to perform specific tasks, as for example, opening a folder or creating a file or moving it or renaming it, and so on. And the main difference between using the command line instead of the computer's graphic user interface is that, especially at the beginning, it may be less intuitive. But the main advantage of working with it is that it gives you more control of what you are doing. So the command line exists both on Windows and Unix operating systems, that is in Linux and Mac OS, but with a core difference in its working principle. Because on the Windows command line, you are using commands as shortcuts to small applications on your computer, such as Bash or SSH, which run the processes you're asking to do. On the Unix command line, instead, you use it to communicate directly with your operating system. So let's see now how the command line works, both on Windows and on Unix, by presenting some of the most common commands. On Windows, in order to open the command prompt, how it is called there, you can open run from start, and then type in CMD, standing for command. On Mac instead, you can launch the command line interface, also called terminal, from the launchpad, and we'll see in a minute. So having a look now at the principal commands, the very basic command for navigating the structure of folders is cd, standing for change directory, which is another name for folder, which is the same both for Windows and Unix, and which corresponds to double-clicking on a folder to enter it. So in order to enter a folder, you type in the command line cd, followed by the path of that folder, starting from your current directory, which by default is your home directory. And as you know, on the computer, files and folders are organized into a tree-structured file system. And if you want to check what is the directory you are currently in, you can type in the command line cd alone in Windows, or pwd on Unix, standing for print working directory, which is the directory you are currently in, and you'll get it. You'll see at which point of the file system you are. So in order to enter a folder which is inside another folder, for example, a folder named text, which is on the desktop, you have to type cd, then a space, then desktop, then a slash, and then test. But be careful here with the slash, because as you can see from the slide, on Windows you have to use between folder names the backslash, whereas on Unix the forward slash, so be careful. And also when you are inside the folder and you want to go up from the current folder to its parent folder, you have to type 2 dots. So from text, by typing cd ... you go back to desktop. Another very common command is dir on Windows and its equivalent ls on Unix, which returns a list of all the files and folders that are contained by the current directory. So dir for directory and ls for list. Then all the following commands are pretty straightforward. So del for delete and its equivalent rm for remove are for deleting a file. Copy and cp for copying a file, and move and mv for moving a file. But for renaming a file, there's a difference between Windows and Unix, because Windows uses rename, whereas Unix uses again mv, followed by first by the file name, and then by the new name that you want to give to that file. And then we have make dir and rm dir, both in Windows and Unix, respectively for creating a new directory, so make directory, and for deleting a directory, so remove a directory. Then on the command line, you can also type help on Windows or man for manual on Unix for receiving support on the use of specific commands. So these are just some of the most common commands you can find, but they will be more than enough for many of the things that you will have to do through the terminal, probably. So now let's see how the command line works in action, first of Unix and then on Windows. So here I'm launching the terminal from the Launchpad. And here you can see on the right, there is the name of my computer, and then my home directory, the tilde, and then the shell prompt, and then the cursor, meaning that the command line is ready to receive commands. So
could you make it a bit bigger, please, Irene? Because it's a little bit hard to see on this screen.
Better.
Lovely, thank you.
Okay, so here, if I type this, I get my home directory, which is users Irene. Here, typing list ls, I'm getting all the folders and files that are inside my home directory. And if I want to enter desktop, I do cd desktop. And again, with list, I can see what's there. And then I have my test folder, so I can enter these. And just to try what we said before about the dots, if I want to go back, I can do cd 2 dots / and again 2 dots to go back to my home directory. Again, I'm going back to test, so cd desktop and test. And let's see what I have here. Here I have some different files, and let's try to do something with them. So I don't like to have a sample one, and I want to delete it. So I can do rm for remove, sample one text, and then list again, and the file is gone. And if I want to rename a file, let's try the move mv. So I may want to rename sample to text as sample to text as sample text, and then find the file renamed. So now I would like to show you also some of these commands on Windows. And I have pre-recorded a short video on using Parallels Desktop. I wouldn't dare using it live because everything would have crashed, so I pre-recorded it. And here I open run, I type cmd. This is my home, changing the folder. Here I have dir instead of ls for having all the files. I'm entering desktop, I'm seeing again what I have here. I'm entering the same folder test. I'm going back with the 2 dots, which is the same, but here I use the backslash instead of the /. Okay, now I'm going back to my folder test and see what's there, the same files as before. And here I use move for moving sample 2 to the parent folder. So here, if I look again inside the folder with dir, I can see that sample 2 is gone. And here, for deleting a file, I'm using del instead of rm. And looking again at the folder, the file is gone too. Let's try also rename. So renaming sample 3 as sample. And again, looking into the folder with dir, I had it renamed. And that's all. So now, Gabby, I leave you to Gabby. Will introduce you to Git.
Great. Yes, thank you, Irene. That's great. So for most purposes, I think it's really useful for people to know how the command line works, because there will come times when you'll want to be able to do things, some of the basic things that Irene showed, and some more advanced things from the command line. But for most purposes, and certainly for what we're looking at today, the only one of those commands that that Irene has shown you that are going to be particularly useful to you are cd for navigating around the file system, and ls for viewing your current listing the content of your current file, or dir on Windows. And certainly, and I'm going to show you a couple of other commands in a few minutes that that you will need to be able to work with Git. But they're again very few and very relatively straightforward commands. So I'm just sharing my screen just quickly, and so I'm going to introduce the concept of working with Git, which is a version control and a collaboration repository software, and then we'll show how that works in practice. So what Git does is it enables you to have a copy of a set of tools, a set of software, a set of files in a shared location, of which you can then make a copy in your local file system, or on a server, or in various other places, and you can make changes to it, and then you can push those changes back to the original. And if other people make changes, they can also push them back to the original, and you can pull their changes to your version before you make your changes and push them back. So it's a platform for collaboration primarily. The main commands you need for Git, these are the command line commands you would use for this, is to set up your local version of the repository. Is you would say git clone, and then the URL of the repository you're cloning, and then the location into which you want to clone it. So first, you go to the right place in your file system using CD to navigate there, and you might create a new folder into which you want to clone this repository, and then you say git clone, and I've given you there on this slide the URL of the Sunoikisis DC 2020-21 repository. There's this is where you'll find the slides for this session, and also any files or other things that we might upload for you to work with in future sessions. And this will then make a copy of that repository on your local file system. When you're working with this this repository in the future, if you want to make changes to this repository, you will first, before you start, you will open up your file system, navigate to the spot where this folder lives, and you will type git pull. That will make sure you have the most up-to-date version of the repository on your local system. If you then make changes to the local files and you want to push those changes back, you have to do three things. First, you have to add them so that Git knows that this is a change you want to push back and not just a change that you've made locally that you want to keep local. And so you use the add command there, git add. You can also delete files from the repository by using git rm to remove them as well. And these don't vary between Windows and Mac and Linux. So these are always as given here. Once you've added, so you've told Git which files you want to be pushed to the repository, you can then type git commit, which pushes them to your local copy of the repository. It commits them to your local copy. They are now under version control. And in order to put something under version control, you have to leave a comment with each, a message with each commit. And so you need to use the flag -m to say what follows is a message, and then in inverted commas you say what it is you've done in this current change. So if I've just pushed a new version of the slides, I might just type git commit -m quotes new version of the slides quotes, or maybe something more useful than that, but something like that. And once you've done that, you can then type git push, and that pushes all your changes, all the commits that you've made to your local repository back to the central repository that everyone is working on, and other people can then pull it. When you've committed, it's still only on your local repository, so no one else can get access to it yet. So those are the command line commands that you will need. When you're working with someone else's repository to which you don't make any commits, you only need to know really clone and pull. But when you're working on your own repository, you will use these other tools. I see someone has commented that we should be using the GitHub desktop. We will be doing precisely that in 5 minutes. This is to give you a sort of theoretical background first. So a couple of words about how people use Git. One is in some ways the most common for small projects is that you make a clone of the repository, you work in your local copy, and then you just keep working there, and you commit to your local copy periodically. Once you've got it working, you then push everything all at once. Okay, so the way to make sure you don't end up with a broken software repository that other people will attempt to pull and find it doesn't work is to make the copy and push it only once you've got it working. The second possibility is to make a branch within the online repo, the central repo, and then only merge that branch back into the main repository when it's complete and when it's working and when it's been approved by the rest of the project. And this is slightly more advanced, but it does mean that other people can get hold of your work in progress as you're going along. And a branch is basically another part of the same central repository, but it doesn't interfere with people who might be pulling from the main part of that repository. If you don't have access to that repository, so you're not necessarily a collaborator on the main project, but you want to make a copy and make do your local changes to it, what you can also do is you can fork the repository into a local copy in another repository that you have control over. And then you can make as any changes you want in that repository. And you might, at that point, eventually also want to make a pull request, which is requesting that the owners of the original repository pull some of your changes back into their repository. If you think you've made changes that will be useful to them, they can then decide whether they want to do so or not. Or you may never make a pull request because your changes you think are not of any interest to anyone, they're just for your local copy. In any of these cases, you are sometimes going to come across the scenario where changes you have made and changes someone else has made have come into conflict with one another because they've changed the same file in incompatible ways. And at that point, various methods for resolving those conflicts are going to be necessary. I'm not going to go into that in any more detail now. So what I want to do now is demonstrate a couple of these things at the GitHub site. And the first thing I want to show is the concept of making a fork, because this is something that we are going to want to do. Those of you who are following this as part of a program, in 2 weeks' time, we're going to ask you to make a fork of the FS code set into a repository on your GitHub account and make your own changes to it there. So from here, if you go to the main page on GitHub for the FS repository, for now this is just an example. There is a command up here on the right which is fork, and you can fork it to any one of the accounts that you have access to. And in most people, you're going to have your named account is the one you'll be interested in. I happen to have access to several other accounts, but I simply click on this one because that's the named account I want to fork it into. And as easy as that, it's now forking it for me. And in a few seconds, this will appear. So FS before had the address github.com/epidoc/fs. I've made a copy of that at github.com/gabriel/fs, and I can make any changes I want to this, and it won't affect the main repository. And this is again what we'll ask you to do in a couple of weeks. I can then, using either my command line, as we just showed, or using the GitHub desktop interface, which I'll also show you, I can go here, and as Irene showed, I can navigate to, if I can remember where these things live, to my where do I want to go? Oh, I see. It went all the way to root. Users. Maybe it's a step more complicated than I meant it to be. So I go to Documents, GitHub, and so this is a folder where I keep my GitHub repositories, and then I'm going to make a directory called something arbitrary. I've just given it a new name, and then I'm going to git clone this address here from the FS from my fork of the FS website into here, and I'm going to say put it in the fs-gabby folder. And it clones this repository, and it's a fairly big repository, so this will take a bit longer than the few seconds it took to clone it. But as you can see, it's already done nearly 15% of it. And this is then making a copy on my own computer. So we don't necessarily need to sit here and watch all of this happen. What I'm going to do instead is show you a tool which most of you will probably find easier to work with than the command line. So this is the GitHub desktop tool. If again from here, if instead of I'm going to code and copying the URL, instead you say open with GitHub desktop, what it will do is it will ask you to install this piece of software, and then you can simply go to this piece of software and you can say, I want to add a new repository. You will have this part will be blank. I've got several repositories checked out already, but you can say, I want to clone a repository onto my desktop, and I'm cloning it from github.com. and it wants me to sign in, which could be awkward if I don't remember my password. I should have checked this was logged in before I did this, but I think it's worked. So from my repositories on github.com, when I'm logged in as myself, I can find, yes, my repository called GitHub FS, but I've already checked that one out, so I'm not going to do it again from here. I'm going to go to Sunoikisis, which is, again, your list will be a lot less long than this if you've just created an account. So I'm going to go to Sunoikisis, and I'm going to check out the 2020 to 21 repository. And it turns out I've already checked this one out, so I'm not going to do it now. But the only step that I'm not demonstrating to you is clicking on this clone button, which now is grayed out for me. But when you do it, that won't be grayed out. You'll click on that. You'll have then a local copy of it, and in fact, I can pull up the local copy on my computer, and I can work on it there. Once you have that cloned, it's at that point, up to now, it's more difficult than the than doing it from the command line, because I've had to remember where 2 or 3 different drop downs are and so forth. Whereas on the command line, it was only 1 line of code. But from now, when I want to git pull, I simply click on fetch origin up here, and it checks to see whether there's anything new online. When I want to commit, I simply go to the changes tab up here. So the history tab here tells me all the changes that have been made to this repository in the past. The changes tab tells me what local changes I have made, and I can commit those changes by leaving a comment in here. This is the equivalent of typing commit -m. And then I can click on fetch origin again, and that pushes them for me. So it's all done from this interface, and it's much more straightforward. So this is the interface that I suspect most of you will want to use the first time you're using Git. It'll be that much more straightforward. I think that's as much as I wanted to say just now. Did we miss anything? Nope. Okay, then we can take questions or comments from the YouTube live chat. There are a couple in here already. There's a question from Anisa, which is, there's a key that is very useful, and this is in reference to the command line presentation, I think, which repeats the entire path of directories, but she doesn't remember what it is. I'm not sure I understand.
If for repeat, it means she means to get the path to the current repository. It was PWD, right. But I'm not sure.
So what I thought possibly she meant was that if you've had to enter a directory path once, and then you want to enter the same directory path again, rather than having to type the whole thing out again, you can press the up arrow key, and that will give you your last command, and then you can go and edit it. And maybe, so maybe if you've done CD once, and then you can do ls to do that second time. So she was in fact asking for PWD, but if you've had to type in a long command, pressing up will normally take you back through the last few commands, or possibly up to hundreds of commands, depending on the buffer, to go through those, and that can be a time saver. The other thing that I possibly thought she might have been asking, but clearly wasn't, because we've already established that, was if you have a long file name, rather than having to type the whole thing in, if you type the first couple of characters so that there's only one file it could possibly be, and then you press the tab key, it will auto-complete that file or directory name for you. And if it's still ambiguous, it'll usually beep or it'll complain, or it'll give you a set of options that that you might mean. So that's something that's often used as a time saver. You'll see people using the command line just pressing tab to get through much more quickly. As someone else pointed out, yes, unlike my slides, all those commands should be in the lowercase. It should be Git in lowercase. I think my slides, that was just, you know, PowerPoint automatically sentence casing my bullet points helpfully. Does someone want to say something about Clifford's question? What is the advantage of using, sorry, clicked on the wrong question. What is the advantage of working with the command line over using the desktop interface? Is it just a matter of preference, or is there something greater at stake?
Well, maybe at the beginning, if you are new to Git, you can use the desktop interface. It depends, but in my experience, at least, the desktop interface is not necessarily easier than the command line. The problem is that the command line maybe at the beginning something, well, of course, you have to learn how to use the command line, and the desktop interface definitely helps to try to begin to use and to work locally on. It's easier, but then you lose, okay, the ability to work with Git. So we are not here to recommend the command line or the desktop interface. And in fact, at the beginning of this session, we were discussing if we had enough time to present also the desktop interface or not, but definitely it's important to present both. I don't know, Gabi, Irene, or Paul, if you have other impressions or your experience.
Well, it's much a matter of preference. I think that if you don't want to install an additional software on your computer, you can just do the very same things using the command line. There's nothing that you can do from there. So I prefer personally the command line, but it's just a matter of preference, I think.
And it depends what you're using it for. So Irene showed how you use the command line to do, and as she said, things that you can do by pointing and clicking and dragging on with your mouse on the desktop. Now, if you can do those things by pointing and clicking and dragging on the desktop, then why not do that? Usually, if I want to move something from one folder to another, I go to my desktop and I drag it from one folder to another. But sometimes you want to do other things. You want to make sure you're copying something. You want to make sure you drag it and give it a new name in the new folder. And that's something, sometimes you have and sometimes there are folders that have security preferences, so you can't actually copy something into a folder without giving a root password to your computer in order to do so. And so for that, it's much easier to do that from the command line. There are various things that will be useful to do from the command line, and people who do a lot of those sorts of things sometimes get into the habit of doing the simpler things on the command line as well, just because they're used to that interface, and that's the interface they're using. And the same applies to Git. Cloning and pushing and pulling and so forth on Git is sometimes simple enough, and they do everything else on the command line. So why not do that there as well? You'll have noticed, or you may notice when I demonstrated the GitHub desktop tool, that the button for Git pull and the button for Git push is the same button. Which, if you want to do one and not the other, then you can't do that from the desktop tool. You have that's a level of granularity that you can only do from the command line. Now, usually you always want to pull before you push, and if you've got committed changes, you probably want to push. So the GitHub desktop is, again, fine for most of us, but sometimes you want to pull, make sure you've got those changes, but you're not going to push your commits until the end of the project. And that's something that the GitHub desktop might cause you to accidentally push your commits when you didn't want to. So having a little bit more control from the command line is something that some people like. I've never found that to be a problem, but it is one reason that people prefer that. Likewise, if you end up with a commit conflict, someone else has pushed files that conflict with your files, and you need to merge them. There are all sorts of sophisticated merge commands in Git, which you can use from the desktop. which the from the command line, which the GitHub desktop tool doesn't have with quite the same level of granularity. So if you want to make sure you're not accidentally merging things in a way you don't like, you might want to do it from the command line. In any case, it's useful to know about the command line, because sometimes your software will crash, or you'll find you're not on your own computer and you want to make some changes to Git, or something has gone wrong and you need to do something much more technical with Git, that you may not have learned all the commands. I mean, I certainly haven't learned all the commands, but sometimes I'll need to do something really technical, and I will Google until I find the exact commands I need, and then copy and paste them into the command line, and that's given me a certain amount of control over over to fix a problem with the repository, for example. So if there's no other questions, and do point out if I've missed any, but the one other thing we wanted to just finish with quickly then is to, as an exercise, and particularly if you're following this program as part of a coherent course over the semester, is to go to GitHub, make yourself an account if you don't already have one. And then that will give you an account. It'll give you a page on GitHub, which is github.com/your-name, in the way that mine was github.com/Gabriel Bodard. And you then go in and tell it to make a new repository, and you can call it Sunoikisis 2020 or whatever you want to call it. That's your repository for playing around with this semester, and that's where you will commit the exercises you do, any files you create or any files you modify. That's the repository into which you will put things and play around. Later, you will also make a new repository, which will be a fork of FS, for example. But for now, create a repository for yourself, and make sure that you initialize your repository with a README file. Now that's a command which GitHub does for you by default, or allows you to switch on and off. So it sounds complicated, but it really is just a matter of saying, yes, I want to initialize with a README file. Do so. You can edit your README file to say something, this is why I've created this repository. And then make sure you can, either from the GitHub desktop tool or from the command line, as you prefer, make sure you can pull, clone and pull your repository, make changes to your README file, commit them and push them again, and that they appear in the repository. So just check that all of those things work. That should get you nicely set up for things you'll need to do over the next few weeks. Did anyone else want to say or add anything before we go? Okay, in that case, join us again next.
You're muted.
Gab, you've muted yourself half sentence.
I don't know how that happened. Thank you.
We have one last question from me.
We do. Git doesn't need or use the rewrite and execute permissions. Not normally, no. No, that's something you use for pushing to a web server. Yeah, no, that's not something you'd use for Git. Yeah, so next week we'll be talking about markup. It would be probably useful if before the session you install, and we're recommending the Sublime Text.
Or Sublime Text or Atom editor.
Right. But I think we're recommending Sublime Text. If you prefer to use Atom, which is another text editor, you can do that. So install one of those two tools, and then we'll that'll be the tool we use for the exercise in that session. And make sure you've got your Git repository working, because you'll make the changes in there. Cool. Then thank you all very much. Thank you, Monica, Polly, and Irene, and see you all next week.
Okay.
Ciao.
Thank you. Ciao. See you next week. Ciao, ciao.